Hello everyone and welcome back. My name is Mr. Cobalt and today we're going to do another problem where we are going to convert mass to mass using a balanced equation. So once again, our balanced equation is going to be used to get the mole ratio, and then we're going to need to use molar masses to convert from grams to moles. So again, let me go over the conversion highway, the chemistry conversion highway here. And so this is a useful tool to remind us how we're going to get to where we are going to go. And so we need to know where we're going to start. And then once we know where we're going to start, we then can follow the path or follow the roadmap to get to our destination. Now, there are a lot of times the problems that we are given, we have to start outside the roadmap or off of the main highway. So we're going to start on a local road, if you will, and we're going to enter onto the highway. And then once we're on the highway, the road will tell us where to go. And we may need to get off of the highway too. So this is a good example of that as well. So here we have the problem. It says, here is the equation where sulfur dioxide reacts with oxygen and water and creates sulfuric acid. And this is basically the production of acid rain. So in this problem, we're saying if a medium-sized home produces 25 kilograms of sulfur dioxide per year, what mass of sulfuric acid in kilograms can form from this much SO2? So basically they're saying, okay, so they're giving us an amount, a mass of SO2, and they want us to convert that to an amount of sulfuric acid. So how much sulfuric acid would be produced from that amount of SO2? So this is a mass to mass conversion. So, but however, they're telling us to start with kilograms. The road map starts with grams, so we're off the road. So we need to start with kilograms here, and we need to go to grams. And then when we're on the road, then we get to a mass of B in grams, but they want the mass of sulfuric acid in kilograms as well. So we're going to need to get off the road and go to kilograms as well. So, and a lot of times we're going to be off the road, but we can get onto the road and off the road with other conversion factors. So we're going to start with what they give us, which is 25 kilograms of sulfur dioxide. So if we write down 25, and let me make sure I have the right sig figs here. And so yes, it's 25 kilograms. So we have 25 kilograms of SO2. And so what do we need to do? Right, so we got kilograms, we need to get onto the highway. So we need to get grams. So we can go from kilograms to grams using our metric system, and we can use the metric prefixes to figure out what our conversion factor is going to be. So once again, we relate our prefixes. So the base unit is going to be related to the prefix. And so I always put, again, you always put 1 with the prefix. That's because if we know what the prefix multiplier is for the prefix, that will go with the base unit. So for kilo, that's going to be 10 to the third. So 10 to the third, or 1,000, is going to go there. So that's our equality. We can now use that to convert. So we're going to convert to grams. So kilograms is on top. So we're going to put 1 kilogram on the bottom, 1 kilogram of SO2. And then on top, we're going to put 10 to the third grams of SO2. So kilograms of SO2 cancels out. Now I have grams of SO2. Now I'm on the chemistry conversion highway. So now I just follow the steps to get to mass of B. So I'm going to use my molar mass of my SO2 to convert to moles. So that's going to be my next conversion factor. I have the molar mass written up here, so 64.07 grams per mole. So I have grams on top, so the 64.07 grams of SO2 goes on the bottom, and 1 mole of SO2 goes on top. So the grams cancel out. Now I'm left with moles of SO2. So now I'm here. So I've moved here to my destination. I still need to keep going. So now I need to go from moles of A to moles of B, moles of my SO2 to moles of sulfuric acid. And there I'm going to use my mole ratio from the balanced equation. So the coefficients are going to be the mole ratio. So 2 moles of SO2, 2 moles of H2SO4. So I'm going to just use the coefficients. Now you might want to simplify and go 1 to 1, but I stay away from that because when you simplify, that's an added step that you might make a mistake. So just use the coefficients in the equation and you won't make a mistake, right? So they're there for a reason, so use them. Let the calculator do all the simplification for you. So I always write down whatever the equation tells me. So here it's 2 moles of SO2 to 2 moles of sulfuric acid. So I'm going to put 2 moles of SO2 on the bottom, 2 moles of H2SO4 on the top. So the moles of SO2 cancel out. Now I have moles of sulfuric acid. Now I have moles of B. So my next step is to use the molar mass of sulfuric acid to convert to grams. So here I have the molar mass of sulfuric acid. So I'm going to use that. And so now this time, the moles of sulfuric acid are going to go on the bottom. So 1 mole of sulfuric acid, H2SO4. And then I have 98.9 grams. So 98.09 grams, 0.9 grams of H2SO4. So moles of H2SO4 cancel out. Now I have grams. So I'm right here on my road map. I'm at the end of the highway. So now I need to get off because the problem is asking for kilograms of H2SO4. So I need to convert from grams to kilograms, so I need to go back to my equality right here, my equality right here. And so I'm going to then do my last conversion. And so since I have grams on the top, I'm going to put grams on the bottom. So 10 to the 3 grams. So 10 to the 3 grams of H2SO4. And 1 kilogram of H2SO4 on the top. So grams of H2SO4 cancel out. Now I have kilograms of H2SO4. They want kilograms of H2SO4, so now I am done. So now all I need to do is take my calculator and calculate the answer. So I start with 25 and multiply across the top, divide by what's on the bottom. So 25 times 10 to the 3, which is 1,000, times 1 times 2, I skipped the ones, times 98.09 times, and then there's a 1. Okay, so divided by, skip the 1, 64.07, 64.07, divided by 2, and then divided by 1,000, 10 to the 3 equals. And I get, for an answer, 38.2. So 38.2. 2745, and that's going to be kilograms of H2SO4. So that is the answer that the calculator gave me. I'm not done yet. I need to figure out how many sig figs I'm allowed in my answer. So once again, you're only allowed the same number of sig figs as the least number. So you got to go through and eliminate anything that is exact. Okay, so looking here, the 1 kilogram to 1,000 grams, that's exact because we have a metric mass to metric mass. So that's exact. We ignore that for sig figs. This is molar mass, that's a measure. This is our mole ratio, that's going to be exact because those are not measures, they're exact numbers. Molar mass is a measure, so we got to look at that. Again, kilograms to grams, that's going to be exact, so we're going to ignore that. And then this is what they gave me, so that's a measure. Okay, so I have 4 sig figs here. I have 4 sig figs here, and I have 2 there. So the least number is 2, so I'm only allowed 2 sig figs in my answer. So I got to cut it off here. This is a 2, so this is going to stay 38. So the answer is 38 kilograms of H2SO4. And so that is the answer that I would report, and that's it. So I hope this was helpful. So again, when you're doing a mass-to-mass conversion, you're going to be using your balanced equation to get the mole ratio, and you're going to use the mole, the conversion, chemistry conversion highway to tell you how to go from to start where you're going and to get where you're ending. And that's it. I hope this was helpful, and if you like this video, share the video, like the video, subscribe to the channel, make a comment in the comment section, let me know what you think, and if you have any questions. Make sure you hit the notification bell at the top, and so that way you can get notified of any new videos I put out. Thanks for joining me, and I'll see you next time.